Assalamu alaikum. So it's our 10th lecture of principal methods and applications of nuclear tracks, and in this lecture we will discuss about the study etching methods and evaluating different parameters. So first of all, you must have to know what is etching, what is chemical etching. So chemical etching is basically a process of path formation in the detector. Okay. During a suitable etching solution attracts a detector at a sufficient speed. Okay, and the damaged region along the ion trails, you can say that latent track are professionally dissolved or removed and get transformed into the hollow channel. And in this etching, chemical etching, the most common etching for plastic is the aqua solution of NaOH and KOH. Okay, with concentration of 1 to 12 molar. Okay, and basically the temperature is between at the range of 40 to 90 degrees Celsius, and most common temperature for where the tracks mostly found is 70 degrees Celsius. Okay, there are several devices used for etching as NDTs, like water bath, which we are taking in this etching bath. You can see water bath, microwave and ultrasound, and all of them provide heat to the etchant solution in the addition to specific waves in the microwave and the ultrasonic devices. So you can say that the geometry of track etching depends on chemical etching, which I told you previous. Okay, so depends upon chemical etching solution along you can say the particle tracks at linear rate Vt. Okay, Vt is basically the track damaged part, you can say. Understood? And the general attack on the etched surface and on the interior surface of the etched track at a lesser rate Vb, and inside you can say it's Vb, and it is denoted by bulk, and it's so called as the undamaged part. Understood? So how you can define Vb, which is the bulk etched rate? So you can define the Vb is the rate of at which the undamaged surface, because you know that Vb is basically undamaged part, so Vb is defined as the rate at which undamaged surface of the detector is being removed during chemical etching. Understood? And its relation is basically Vb equals to d by 2t, where d is the diameter of the track and t is basically the etching time. Understood? Now let's move towards the track etched rate, or the etched rate along the latent track was calculated. As you know that the latent track, which is denoted by Vt, and it's basically the damaged part. Understood? So the track etch, or you can say the etched along the latent track Vt, have a relation of this: Vt equals to Vb 1 plus Vd by Vb square divided by 1 minus Vd by Vb square. Okay, and this Vt is basically track etch rate, or you can say that it can be so called as the latent track. Okay, etched rate along the latent track. And here Vb is again the bulk. Okay, bulk etched rate, whereas Vd is basically the rate of track diameter. Understood? And Vd has a relation of d by t. Understood? This Vd is basically the diameter of the diameter rate of the track, which can be calculated from the slope. Understood? And Vd has a relation of d by means del d divided by del t. Okay, between the track diameter and the etching time. Now let's move towards the etching rate ratio. How you can find the etching rate ratio, which is denoted by V. This is the etching rate ratio, which is denoted by V, and it's the ratio between Vt over Vb. So etching rate ratio can easily be calculated by dividing the average of Vt on the average of Vb, as shown here. Okay, so V equals to Vt by Vb. Now move towards the critical angle. Now what is critical angle? Denoted by theta c. Critical angle of etching, it is so called as. How you can define the critical angle of etching? So critical angle of etching is basically the determining the appearance of the etched track. Understood? It represents the minimum angle at the etched track would appear on a detector. Okay, it's basically the minimum angle of the etched track that would appear on the detector. Okay, and there are certain critical angles for each detector type. It's calculated from all cases of our equation, and our equation is this: theta c equals to sine inverse of vb by vt. Okay, bulk track divided by latent track. Understood? So this is how you can calculate the critical angle. So it is basically minimum angle at which the each track will appear on a detector. Now lastly, what we have to discuss is basically the efficiency. What is the etching efficiency denoted by symbol eta? Understood? So etching efficiency eta is the rate between the number of tracks etched in the nuclear track detector to the number of incident particle on it. Okay, so basically output divided by input, you can say. It is calculated by an equation, and this eta equals to 1 minus vb by vt. So how you can define the etching efficiency? It is the ratio between the number of track etched, okay, means number of track which are etched in a nuclear detector, to the number of incident particle, means the tracks which are detected divided by the total number of particles. This is how you can find the efficiency. Input divided by output, you can say in simple words. So your eta is defined is equals to 1 minus vb by vt. So this is how you can find etching efficiency, how you can find the critical angle, how you can find the etching rate, which is the ratio of vt by vb. So that's a short lecture for today for principal methods and applications of nuclear tracks. So that's all for today. We will upload more interesting lectures for this course. Okay, if you forgot to watch previous lectures, you can watch. Our playlist is available in our YouTube channel. So if you have any query, you can just leave a comment below. We will definitely answer you in the comment below. If you have to discuss in brief, in detail, so just leave your mail. We will definitely connect with you and answer your questions. So thanks for watching. Stay tuned with us. We will update you. Till then, take care and Allah Hafiz.